Hello there, welcome to my channel. Okay, in this video I'm going to explain to you about the chemistry paper 2, the 23 October November 2021 paper. The time duration for this paper is 45 minutes. Okay, let us move to the first question. Okay, number 1, Brownian motion and the diffusion of the gases provide evidence for the particle nature of matter. Which row identify as example of a Brownian motion and how molecular mass determines the rate of diffusion of gas molecules? Okay, for your understanding here, the more heavier, okay, this is the RMM or RAM, okay, the RMM, it is more heavier, it will become much more slower in the rate of diffusion, okay. Slower rate of diffusion. So let us look at one by one here. Okay, pollen grain in water are seen to move randomly. Okay, and this is the same for this B and C. Salt diffuse faster in hot water than in cold water. This is a rate of diffusion. So they have two examples over here. Let us look at diffusion part. Heavier gas molecule diffuse more quickly. Lighter gas molecules diffuse more quickly. So your answer here should be lighter gas molecules diffuse more quickly. Alright, so this is wrong. And we have, okay, for the particular nature of matter, alright, they want an evidence. So the best evidence here will be pollen grain, because pollen grain can be seen in a microscope. However, for salt we have a very hard time to see their molecule movements. Alright, so the B is the one, the best answer over here. Okay, now let us go to the second question. Okay, now number 2, a student put exactly 25 centimeter cube of dilute hydrochloric acid into a conical flask. The student added 22.5 gram of solid sodium carbonate and measure the change in temperature. So which apparatus does the student needs to use? Okay, obviously we need to have a balance for this. Okay, balance to measure the mass, and we need to have a thermometer. Okay, thermometer, and we also need something to measure this 25 centimeter cube of dilute hydrochloric acid. So for this small amount we have to use pipette, alright, and not the measuring cylinder. So we have to use pipette, so which gives, there is no time over here, so stopwatch is not necessary. So here we have balance, pipette, and also thermometer. So your best answer here will be C. Okay, now for question number 3. A student separates sugar from pieces of a broken glass by dissolving sugar in water and filtering off a broken glass. So this is filtrate and this is the residue. So what is the filtrate? So filtrate only contains the sugar solution. Okay, sugar solution. If you want to have a pure water, then you have to do at least a simple distillation process. Okay, same like a salt water. Okay, now we move on with question number 4. Okay, number 4. A nucleus of a particular atom consists of 19 particles. 19, and this is nucleus. Nucleus is 19. Okay, this is the X. 9 of them are positively charged and 10 of them are uncharged. So which means the proton number here is proton number here is 9. Electron should be the same because this is an atom they mentioned. Okay, and neutron should be 10 of them, so here should be 9. Which statement about this nucleus is correct? So proton number is 9. Nucleon number, okay, this is nucleon, yeah. This is proton, electron, neutron. So this is nucleon, big N, nucleon. So nucleon should be 19. So this is wrong. Nucleon number of 9, this is also wrong. Proton number of 10, so this is also wrong. So your best answer here will be C. Okay, which description of brass is correct? So brass is an alloy. Okay, brass is an alloy. It's a mixture. So they have copper and zinc. Okay, copper plus with zinc. So your answer here is A. Definitely is A. Okay, now we look at question number 6. Okay, now here let me try to make it bigger. Yeah, okay. So now group 1 element combines with the group 17. Okay, this is a group 17 and forms an ionic bond. Which row shows how the electron structure changes? So group 1, they'll form a metal. They will donate 1. Okay, they'll donate 1 electron. So let me make it a bit smaller so I can do an equation here. So group 1, okay, so they will donate 1 electron. However, group 17, they will accept 1 electron to form the positive ion. Okay, so this is the difference. So before bonding, they must have 1 electron. Okay, 1 electron. And after bonding, they have to donate. So this is correct. And before bonding here, they must have 7 because it's group 17. So they must have a valence electron of 7. And they will add 1 after the bonding. And they will become 2.8. So this is the best answer here. 6 is C. Okay, now state number 7. Which statement describes an attractive force between molecules? Okay, attractive force between molecules here, they will be referring to covalent bonding. So it is you should have the answer. Okay, look at ionic bonding. Ions, anything to do with ions over here is wrong. So we have to look at answer A or C. So here we have a strong covalent bond which holds molecules together. And C is a weak force formed between covalently bonded molecules. Okay, so here, so they're asking for attractive force between molecules. So which means that, let's say we have 2 molecules over here. Okay, so inside is a strong covalent bond. Okay, inside is a strong covalent bond. So when you're talking about attractive force between molecules, which means the forces over here between the molecules. So this is normally is weak. This is what we call as a van der Waals force. Van der Waals force. So this should be C. They have a weak force formed between the covalently bonded molecules. So this is what they're asking for. Okay, now let us go for number 8. Which diagram shows the outer electron arrangement in a molecule of a carbon dioxide? Okay, for carbon dioxide. Okay, now let me draw the Lewis structure here. Okay, so this is Lewis structure, Lewis diagram. So we have a carbon dioxide. So carbon is group 14. So they have a valence electron. So we just look at valence electron. So they have 4. Oxygen is 6. So we have to look at the single one, okay, carbon, and put it in the center. Oxygen in between the oxygens. Okay, now you need to have 4 electrons to be stable, and here you need another 2 more, right, to be stable. So what we can do here is we put the carbon 4 electron in this side, okay, and then for carbon we will do it like this. So you have 6 of them. So at this part here you have the double bond, okay. So this is for the oxygen, this is for the oxygen, and this is for the carbon. So each of them they already secured 8 electrons bonding. So here we have a double bonds. Okay, so this is the Lewis structure diagram for carbon dioxide. So let us have a look with the answer here. So your best answer here could be, this is wrong, this is wrong, this is wrong, because here we can see only 2 electrons. So this is much more better. So we can see there's a 4 here. So your best answer here will be A. Okay, now for number 9. Aluminium oxide is an ionic compound containing aluminium ion and also oxide ion. Aluminium hydroxide is an ionic compound containing aluminium 3+ and also hydroxide ion. In which row are the formula of the aluminium oxide and aluminium hydroxide is correct? So when we add it on, here you have aluminium 2, oxygen 3. This is for aluminium oxide. For aluminium hydroxide, so please remember this 3 will go down here, and make sure you have to put the bracket and put the 3 over here. Okay, so this is the very basic question, and your answer here will be A. Okay, now we'll move for number 10. Okay, for number 10, evaporation is observed at the negative electrode, which is cathode, during the electrolysis of a concentrated aqueous sodium chloride. Okay, concentrated aqueous sodium chloride, we have NaCl. Okay, now we list on with the ions. We have this with hydrogen, chloride, and hydroxide. So over here, both of these will go to cathode. Okay, this one will go to cathode, and here will go to anode. Okay, so what happened at the negative electrode, which is the cathode? If you look at the electrochemical series, okay, electrochemical series, the hydrogen is the most lowest, okay, compared to the sodium. So we will have, it accepts electron at cathode and it will form hydrogen atom, and eventually it will be combined with another hydrogen to form a hydrogen gas. So here we have here hydrogen. Okay, so this is for number 10. Now let us look at number 11. Okay, now for number 11, the energy level diagram for a chemical reaction is shown below here. This is energy, this is the progress of reaction, reactant, product, and let me list down some more. Okay, here will be the energy changes. So in this case, it is endothermic because it's rising. Okay, so you have a positive here, so this is endothermic reaction. And if you look at this, this is the activation energy. Okay, this is the activation energy required by the molecules to produce the product. Okay, now which statement about this reaction is correct? So if you look at it, it is endothermic. So endo we have 2, and energy is given out to the surrounding. If it's given out, it is exothermic, so which is incorrect here. So energy is taken in from the surrounding. Yes, this is correct. So 11 is boy. Okay, we move on with number 12. So number 12, chlorine react with the ethane to produce chloroethane and also hydrogen chloride. Okay, so this process is exothermic. Okay, now this is the bond energy shown in the table. So now I'm going to do a small calculation over here. For this reaction, the reactant, right, they need to absorb energy. They absorb energy to break the bond. So let us calculate this. CH. Look at here. 1, 2, 3, 4, 5, and 6. So here we have 6 times 410. Multiply with 410. Then we look at others. Okay, carbon to carbon, we have only 1. So which is a 350. Chlorine and chlorine. So here we have chlorine and chlorine 240. Okay, now we add on all the values over here. So I'm getting here about 3060. So same thing, we are going to do it at this site, but this site is different. They will release the heat. Okay, they will release the heat to form the bond. Okay, this is to break bond. This is to break the bond, which is endothermic, and here will be releasing the heat to form the bond. So here we have chlorine to hydrogen. Sorry, this is carbon and hydrogen. Carbon to hydrogen. 1, 2, 3, 4, 5. So we have 5 times 410. Carbon to carbon is 350 over here. And hydrogen and chlorine, we have 430. And lastly is this, carbon and chlorine, we have here about 340. So we add on both of this. So here we have about 3170. So this is basically it's a negative value because it is releasing the heat, and this is a positive energy because it's absorbing the heat. So now we have to plus both of this. Okay, take this and plus with this. So here you'll be getting about, so I'm getting over here about negative 110. Okay, oops, I think that I missed some numbers over here. Hydrogen 10. Let me just give me a few moments. Let me check this. Hydrogen, carbon 430, carbon 300. Okay. Sorry guys, it's my mistake. Here should be 3050. Okay, 3050. So which makes sense for negative 120. Okay, so this is your answer. Your answer is boy over here. Okay, so I hope you can understand this question. So now let us move on with question number 13. Okay, number 13, what is the concentration of solution when 31.8 gram of sodium carbonate is dissolved in water to make a solution of a 250 centimeter cube? So we have to convert this sodium. Okay, sodium, the RAM is 23, carbon is 14, oxygen is 16. Okay, so we have to take this and divide with the total RMM. So 23 times with 2 plus 14 plus 16 times with 3. So here we have 3 oxygen. So if we add on all this, we will be getting 48. So it's about 110. Okay, 110. So which gives you 0.294444. So this is the mole. Alright, so to get the concentration, we need to have it is the concentration mole divided by the volume. So here mole is 0.294 divided by 250 divided by 1000. Okay, so we have to change this into dimetric cube as well. That's why I divided with 1000. So I'm getting here the answer of 1.177 mole dimetric cube. So we can simplify this as 1.2. Okay, so this is the answer for this solution. And for number 14, a fuel cell is used to generate electricity. Which chemical are used in the fuel cell? So fuel cell will be hydrogen and oxygen. So they will have a combustion and produce the water. This is the waste and will be recycled again. Okay, so hydrogen and oxygen. This is your answer for number 14. Okay, for number 15, sulfuric acid is manufactured using a contact process. One of the reaction is shown below. Okay, this is the condition. This is the process where we need all the pressure, temperature, and also the catalyst. Okay. Statement 1. Equation has more molecules on the left hand side than on the right hand side. This is exothermic. Okay, using a high pressure shift the equilibrium to the left. Higher temperature increases the rate of reaction. Increasing the temperature shift the equilibrium to the right. Okay, let me explain to you in this small table. Here's the endo and exo, temperature and also the pressure. So for endothermic, we have to increase the pressure while reducing increasing the temperature and reducing the pressure. Okay, that's what will makes it shift to the right. However, for exothermic like this, increasing temperature doesn't make sense because it will release more heat. So we have to reduce the temperature and increase the pressure and it will shift to the right. So if you look at all the statements, increasing pressure shift the equilibrium to the right. This is exothermic, so which is not right. Okay. Now look at number 2. Higher pressure shift the equilibrium to the left, so which is not right. So this is also wrong. Statement 2 and 4. Now number 1, the equation has more molecules on the left hand side than on the right hand side, which is true because this is the reactant and this is the product. And statement number 3, higher temperature increase the rate of reaction. This statement is different from this statement because this one is like a more to general. Okay, so your best answer here will be 1 and 3. So which is statement 1 and 3 are correct, B. Okay, now let us look at number 16 here. So for number 16, iron 2 chloride solution react with the chlorine gas. The equation is shown below here. Which statement about this reaction are correct? So we have iron 2 reduced to iron 3. This is not right. This is wrong. It should be oxidized. So number 1 is wrong. So confirm A is wrong. And chlorine act as a reducing agent. Chlorine is supposed to act as an oxidizing agent because it helps oxidizing this. Okay. So this one should be oxidizing agent. Now look at number 3. Iron 2 plus iron each lose an electron. Yes, it's correct. They have to lose one electron in order to form 3 plus iron 3 plus. Okay. Number 4. Chloride molecules are reduced to chloride ion. So this is correct. They are reduced. So 3 and 4 is correct. So your answer is donkey here. Now let us move to question number 17. Okay, number 17. Excess dilute hydrochloric acid is added to equal mass of powdered calcium carbonate in 2 separate experiments. Okay, 2 different concentrations of acid are used. The temperature in both experiments is the same. The result shows the change in mass of the reaction flask measured over time. So this is the results. Let me make it slightly bigger. Okay. So here is a mass of a reaction flask. And remember the acid is in excess. Okay. Acid is in excess. So y is the rate of reaction for 1 mole dimetric cube of a hydrochloric acid slower, because you can say the collision energy okay, now we're focusing over here. So the collision energy and we have a collision rate. So collision energy, no matter like what is the concentration that we are going to use, the collision energy remains the same. Okay, but the collision rate will differ, slower or higher. So the more concentration, we will have a higher collision rate, and lower concentration, we will have a lower concentration rate. So should be D as your answer. Okay, numbers 18. Basic oxide are neutralized by acidic oxide. Which element forms an oxide that neutralizes calcium oxide? So calcium oxide is a group 2, right? So this is an alkali. So we need something to do with acidic. So magnesium is a group 2 and this is a group 1. So both of their oxide will form an alkaline. So it doesn't make sense to mix with this. Hydrogen oxide will form water. So the best answer here will be sulfur. Sulfur is a group 16 and their oxide is much more acidic. Okay, so 18 you have a D as your answer. Okay, now we move on with question number. Okay, for 19, 4 solid oxide are added to dilute hydrochloric acid and aqueous sodium hydroxide. Which row describe amphoteric oxide? Amphoteric means it can act as an base and also as acid. So you will have a reaction for both. So your best answer here will be an A, because they can react with hydrochloric acid, at the same time they can react with a sodium hydroxide. Okay, for 20, which row describes an acid and oxidizing agent? Okay, remember acid, it is a proton donor. Base is a proton acceptor. Okay, proton acceptor. Okay, and then at the same time, if you look at here, oxidizing agent normally they will be reduced. Okay, if the certain element is being reduced, okay, example, we have chlorine, okay, chlorine is okay, chlorine at this one, and then they'll accept electron to form chloride ion. So this is a reduction, right? It's reduced. It is reduced. So what happened here? They will accept the electron. So your best answer here will be for acid is proton donor, and oxidizing agent here will be electron acceptor. So your answer here will be C here. Okay, for number 21, a period table is shown. Okay, this is group 1 until the group 18, and here we have all the elements. The letter are not their chemical symbols. Which statement is correct? Okay, element R does not conduct electricity. So you have to understand that the group 1, 2 and 3, this is metal and they do conduct electricity. Okay, so this is not correct. Element R and Y react together to form ionic compound. So this is a metal, R is a metal, and look at Y is a non-metal. Then they do combine to form a ionic compound. This is correct. Now let us look at C. Element Z exists as a diatomic molecule. So this is group 18, and group 18 will form monoatomic. Okay, they'll form a monoatomic molecule because they are inert and stable. They do not react with the other elements, so they do form as a monoatomic. They do not react with other elements. Okay, but atomic molecules is only for group 17. Okay, this is for group 17. So therefore C is also wrong. D, element Z react with element T. So Z do not react with any other elements. Okay, so because they are inert. So your best answer here will be boy. Okay, for number 22, part of the periodic table is shown. Which pair of elements J, K, L, M, N reacts together to form a product with a 1:1 ratio? It means that, example, now we have sodium and chlorine. They will form potassium chloride. So this is 1:1. Okay, another example here is magnesium 2 plus and oxygen 2 negative. When they combine together, supposedly is this, but what happens is, due to their same ratio, you will obtain magnesium oxide. Okay, so this is also is a 1:1 ratio. Okay, so let me erase this example and then we try out with the symbols above. Okay, now this is group 1. So J is positive, K is a 2 plus, the oxidation number. And so the N here is a N negative 1, M is a M2 negative, and L is a 3 negative. So L is impossible to form a 1:1 ratio with this, with J and K. So there is no L over here. Okay, there is no L. Okay, now J can combine with N. Okay, J can combine with N to form 1:1 ratio, Jn, and K can combine with M to form 1:1 ratio. So it's Jn and Km. So your answer here is D for 22. Okay, now let us look at 23. Okay, which property is shown by transition metal but not shown by group 1 metals? Okay, because both are metals, right? Both are metals, so naturally all metals will have a good electric conductivity, good thermal conductivity. They lose electron to form positive ions. Yes, all metals will lose electrons and form the positive ions. Okay, is applied to transition metals as well as group 1 metals. Transition metals will have variable oxidation states. It means that, like example, like magnesium, they have plus, they have 2 plus, they have 3 plus, they have 5 plus, and also they have about 7 plus. But group 1, they only have 1. This is the oxidation numbers. Okay, let us move to 24. The noble gases are in group 18 of the periodic table. Which statement explains why noble gases are unreactive? Okay, they all gases, wrong. They all monoatomic, wrong. You should have a specific reason. They all have 8 electrons in their outer shell. They all. Okay, remember your the group 18 starts with helium. Helium has only 2 electrons. This one will form a duplet configuration, which is also stable. Alright, so this is also wrong. They all have full outer shells. So this is your right explanation here for 24. Okay, 25. Which statement is correct for all metals? They conduct electricity when molten. Yes, correct. They gain electron when they form ions. This is wrong. So which is, they will donate electrons. They have low density, wrong. Low melting point, also wrong. So they have high density and also high melting point. So your best answer here will be A. Okay, 26. Chromium is a more reactive metal than iron but less reactive than zinc. Which statement are correct? So let us arrange the electrochemical series over here. So zinc is on top and iron is here. So chromium should be in between zinc and also iron. So this is the chromium. And okay, let us go through one by one. Okay, chromium does not react with the dilute hydrochloric acid. So this is wrong because most of the reactive metals they can react aggressively with any acids, dilute or concentrated. Okay, chromium oxide is reduced when it is heated with carbon. So please remember, carbon is positioned below the zinc. Okay, so zinc is much more reactive compared to chromium. So when we have mixing with carbon, so it can be reduced. Okay, so number 2 is correct. Okay, here chromium react with zinc oxide to form zinc. So here chromium plus with the zinc oxide. So zinc is already more reactive than chromium. So this one has no effect. Okay, it has no effect. So number 3 is not selected. Chromium reacts with steam to form hydrogen gas. Okay, for number 4, let me explain to you in much more detail. So first, let me erase this and I will write down the electrochemical series elements here. Okay, so as you can see, this is the electrochemical series. The first 5 elements, okay, they can react with the cold water, cold, warm or hot water or steam to produce, they will produce hydrogen gas and also their oxides, okay, their oxides. Okay, however, the next 4 elements, zinc to chromium, they can react with, they'll react with a hot water or steam. Steam is a hot gas to form a hydrogen and also their hydroxide. Okay, so this is their equations. So please remember this. So due to this, chromium react with steam to form hydrogen gas is correct. So your best answer here will be 2 and 4, which is C. Okay. Now we go to question number 27. And let me erase this part. Okay. Number 27. Aluminium objects do not need protection from corrosion. Iron object must be protected from corrosion. Which statement explains why aluminium resists corrosion? Because when you place an aluminium here, a bare fresh aluminium plate, day by day what happens is they will form a layer of aluminium oxide to avoid to protect the aluminium from corrosion. So this layer is aluminium oxide, and inside here is the aluminium. Okay, this is why they do not need any external protection. They can protect by themselves. So they have a protective oxide layer. Okay, number 28. Which statement describes how oxides of nitrogen are formed in a car engine? So as you notice that for engine combustion you need fuel, oxygen, and a spark, right? And a spark. So but this oxygen does not come as a pure oxygen, it comes as a air. So air you have about 78% of a nitrogen there. So what happens is in the engine chamber, okay, in the engine, the high voltage from the spark plug to the engine, it will produce a few hundreds of high voltage that possibly oxidize the nitrogen. Okay, it will oxidize the nitrogen to become a nitrogen oxide and dioxide. So this is the scenario inside the car engine. So nitrogen from petrol is wrong. So nitrogen from air react with oxygen from petrol. This is also wrong. So the oxygen is actually coming from the air. So your best answer here will be boy. Okay, 29. Ships are made of steel, an alloy of iron. Blocks of aluminium are attached to the underside of ships to prevent rusting. Which statement explains how the magnesium prevents rusting? Because magnesium is much more higher position compared to iron. So what happens is this one will be oxidized first. The magnesium will be oxidized first rather than the iron. So this is also called as a sacrificing metal. Okay, now let us look one by one. Magnesium oxidized instead of iron. This one is correct. Let us look at the next one. Magnesium stops air and water getting to the iron. Wrong. Magnesium forms an alloy with iron which does not corrode. This is wrong. The aluminium reacts with rust as soon as it is formed. So this is also wrong. So your best answer here will be A. Okay, so I hope you understand this. Now let us go to question number 30. Okay, number 30. Which process is used to produce hydrogen for Haber process? Okay, Haber process is a hydrogen plus with the nitrogen gas to produce ammonia. Okay, ammonia gas. So the question is, how do they produce this as a raw material for this process? So there are only two possibilities. One is electrolysis. Okay, I just write it down over here. One is electrolysis, and this is a very high cost, and you can also use the normal method that is using that are used in this industry, steam reformation. Okay, steam reformation with the methane gas. So you have two answers here: electrolysis of water and also reacting methane with steam. So the best answer here will be D. Okay, so this is the most common method used in the industry. Okay, now let us look at number 31. One of the steps in manufacturing sulfuric acid in the contact process is shown. Which catalyst is used to increase the rate of reaction? Okay, please remember for contact process you will have a vanadium 5 oxide. Okay, this is a very straightforward question. We move on with the question number 32. The lime, which is a calcium oxide, is used to treat wastewater from a factory. Which substance is removed by lime? So as you understand, the calcium oxide is an alkali. Okay, it's an alkali. So now alkali can react with acid. So ammonia is an alkali. Sodium chloride is a salt, so it is a neutral. So you don't have any effects on it. Sodium hydroxide is also an alkali. So these three, the A, B, C, has no effect with lime. But sulfuric acid is yes. Because acid plus with the base or alkali, you will have a neutralization process there. Okay, so your answer is D here. Okay, number 33. What is the structure of propanol? Okay, alcohol's base formula is this: CnH2n plus 1OH. So propanol C is 3 here. So 3, H is 7, OH. So you should have there, and there is no double bond. Okay, there is no double bond. This is acid. This is sulfuric acid. So which is wrong? And you must have 3 C's. 1, 2, 3. So which means C is your answer. Okay. So this one is ethanol. This is ethanol. Okay, now let us move to question number 34. Okay, 34. Fuel X produce carbon dioxide and water when it is burned in air. So does fuel Y. So fuel Y, what could be X and YB? X and YB. So they should be, okay, you have to understand this, alkane or alkene. When they have enough oxygen, both of them will produce carbon dioxide and water. This is a complete combustion. Alright, this is a complete combustion. So in this case, if you look at it here, for hydrogen, when hydrogen is getting reacting with oxygen, you will produce water. Okay, you will produce only water. And carbon, when they react with oxygen, you will produce carbon dioxide. So there is no carbon and there is no hydrogen here, because they need to produce carbon dioxide and water. So the best answer here will be D. Okay, number 35. What is the main constitution of natural gas? So natural gas is automatically a methane. Okay, so answer is C here, guys. Okay, now let us look at number 36. Okay, which statement describes the member of homologous series? Homologous series means, example, like we have an alcohol. Okay, we have an alcohol. So all the other elements, like example, like a propanol, ethanol, everything will come under the same group. So compounds with the same physical properties, this is wrong, because when the carbon is adding on, like now we have a methane, ethane, and propane, right? It's getting heavier. Okay, it's getting heavier. So they don't have the same physical properties, but they have the same chemical properties. This is the important thing. I want you to understand this. So this is wrong. Same functioning group, yes, all of them will have OH. Okay, for alcohol. The compound contains same number and type of bonding. This is wrong, because when the carbon is increasing, your bonding increases as well. So compound obtained from a same raw material, it depends actually. Okay, So your best answer here will be same functioning group. So your answer here will be boy. Okay, now let us look at question number 37. Okay, let me erase this. Okay, number 37 here. The structure of two compounds are shown. Okay, we have here two compound. Okay, this is an acid. Okay, this is a propanoic acid. Which statement about this compound are correct? They have a same molecular formula. Yes, it is. They have the same molecular formula. And due to their position, okay, if you look at here, due to their position, they have a different chemical properties. Okay, both of these is not the same, but they can be assumed as isomers. So it's 1 and 3. D. Okay, number 38. Some reaction of a substance Q are shown. This is at steam under pressure and a catalyst. You will have ethanol. So here should be ethane. Let me write it down bigger a bit. So this is ethane. So when the ethane is added with the bromine, you will have a 1,2-dibromoethane, which means you have ethane. Ethane is this. You have double bond. Here's H and here's H. Okay, when this double bond is breaked, you will have bromine and bromine. So here is hydrogen. Oops, okay. And add hydrogen and a catalyst. If you add hydrogen, this will become a hydrogenation process, and here you have a ethane. So which means this. So everything is a hydrogen here. Okay. And what is P? So P here will be ethane. A. Okay, now let us move to question number 39. Okay, protein and starch are natural polymers. Which row identifies the method of polymerization of protein and also starch? So both of them will be under condensation polymerization. Okay, let me explain to you what is addition and what is a condensation. Now, when you have ethane, let's say, okay, when you have ethane, so here you have a double bonds. So we just assume the another part here is hydrogen. Okay, now when they add on, what happens is they'll break the bond. Okay, they'll break the bond, and you will form a chain of ethane. So this is we call as a polyethane. Okay, this is called as a polyethane. So this form is, we call it as an addition process. Addition from polymerization. If you compare to condensation, this is a bit different. Condensation. Now, for example, I just put here A with OH, and here I have, let's say I've just put there B with the OH. Okay, this is an example. So what happens is both of them will get combined by removing. Okay, this one is they combine by removing small molecules, mostly is water. So example like A, O and B. This will be combined, okay, and this will be combined. So the rest, the hydrogen and the OH will be separated to form the water. This is condensation. So most of the natural polymers will be having condensation process, condensation polymerization process. Okay, So this is 39. I hope you have a good understanding on this, both addition and also condensation polymerization. Now let us move to question number 40. Okay, number 40, the diagram shows partial structure of a pterylene. So if you notice here, so here we have, okay, most of the things here, you will have a carboxylic acid group. Okay, the another one you will have is, let me just make it a side here, you will have is hydrazide. Okay, hydrazide group. So what happens is they'll be combining the hydrogen and also the hydrazide from here, and they will form this, sorry, double bond O, and you will have the black color box as well. Okay, so this is what happens over here. So now let us take a look. Okay, now from the picture here, what I've drawn over here, you can notice that the black color box, okay, the black color box is actually the OH, right? It's the OH. However, the white color box, which contains the carbon and the double bond, is this. Okay, so you can make a conclusion here. So this is the black color box, and your best answer here will be A, because the black color represents this and the green color one will be representing the white box here. Okay, so I hope you learned something from this video, and good luck for your upcoming exam. Thank you very much. All the best, guys. Alright, so this is for number 20.